Okay. So this talk will be focused in Postgres. It's the main structure database that we use at Adyen. And it will go into some very specific details on how Postgres works. Who here is working with Postgres? Okay, amazing, amazing. Okay, I hope it will not be too boring and too much detail for everyone else. If you have questions about these custom things we do, then you can feel free to ask at the end. Disclosure, there is some information I cannot actually disclose. So that's basically it. Okay, so the first question you might ask is, why the hell do you manage these databases when you have so many cloud providers that could do that for you? Like, why do you take care of buying hardware, racking the hardware, upgrading, patching, backups? Why? Why do you do this to yourself? The answer is simple. Apparently, no one wants to do it for you. Not at least at the scale we run. So if you go to the most common managed services, you see the storage limit is actually 64 terabytes. We have very little databases that are lower than this. Kind of doesn't fit. There are some others that allow you to go a bit higher on the storage. They are not exactly Postgres. They are somehow Postgres. Anyways, that's another discussion. They have a bit of higher limits. Again, I can tell you that we cannot fit most of our databases here. We do some sharding, but it's a custom sharding, of course. Maybe I can talk about that a bit later. So my name is Teresa Lopes. I work as a database engineer here in Amsterdam at Adyen. I hope you are familiar with it. And let's continue. What we will be talking here today? What are actually big databases? We will soon enough find out that it's not all about the size only. It's not only about the size. Then we will talk about how we can start to manage these huge databases. Of course, this would not be a Postgres talk if we didn't talk about vacuum. So we will talk about vacuum a lot. My favorite topic, full disclosure now, I love backups. We will also talk about them. And then I will give you some insights of some optimizations we do to be able to manage these databases. Anyone knows where is this picture?
Adam Tower.
Sorry?
Adam Tower.
Yes. I live close by, so I have lots of pictures. Yes. What exactly is a big database? Let's start on the other end. What is a small database? Imagine you have this countryside road, empty road. Small database, very low traffic, very low TPS. These things are very easy to manage. Like they kind of self-manage. You don't need to do much. But then you can also have very, very big databases like petabytes. But if you don't have lots of traffic, not lots of queries, of course, there are storage concerns, but they are still really easy to manage, to be fair. But now let's start getting some more combinations. You can have a very, very small database, but a very busy one. And these ones start to have problems with concurrency, connection pooling, and so on. Let's make this even more fun and add an additional dimension that is latency. We work primarily with payments, and payments are supposed to be fast. So we have very strict latency requirements for our systems. But this is not exactly what we have at Adyen. What we have is something I call the perfect storm. And what is this? It's essentially massive databases, very, very high TPS or very high KPS, depending on how we want to classify it, very strict latency requirements, and we have lots of hot data that we have to keep around. I will go back to hot data a bit later. And how does it look like? Trying to go home, and I live in the north. So it was a funny week, yes. the first thing I want to talk about is how we can bring balance to the database, or at least to some parts of it. Anyone knows this place? If you don't know, go there. It's really great. It's in Amersfoort, if I'm not mistaken. Yeah. And you can also go there and check the rock. They have this big rock there that's part of the city, the history of the city. It's a nice place to go. What is this thing about bringing balance to the database? You have this huge database, single instance, that is taking care of all of your writes, all of your reads. Why? Just break it apart. Create replicas. So you can serve all of your writes on the primary side, and you can serve all of the reads on the standby side or on the replica sides. And if you need a global distribution because you're a global company and we like to process payments everywhere, you can actually have different layers or more than one layer of replication, which we call cascade replication, which means you have one primary, you have a first layer of replicas, and then you can have replicas of replicas. But nothing is for free. It's, how can I say, whenever you are deciding to go with replication, you need to decide if you want to have async replication or sync replication. And both of them come with trade-offs. You need to decide if it's really important to have your data persisted in two different places before you acknowledge to the application you have the data. In this case, using sync replication at the expense of latency, for instance, because you need to acknowledge that you have the data somewhere else other than the primary. But then async replication is faster, but you know, there is speed of light, there is cables between databases, so there will be lag between the primary and the replica. There might be lag between the primary and the replica. And you also need to consider what is more critical for you. Is losing a replica, losing a primary? How much time can you afford to recover a replica, or how much time you can afford to recover a primary? What's the effort of rebuilding these things? There are lots of things I could say about sync, async. The only thing I want to tell you is there are trade-offs and you need to be aware of them. If you really want to know a bit more about into detail what are these trade-offs, I would definitely recommend you to check these two amazing talks. Full disclosure, I work with Dimitri. He's a very brilliant person. So go and check the talks if you are curious. Vacuum. This is an interesting one. So if you work with Postgres, you cannot simply avoid vacuum. It's just how the database works. Sorry to break it to you. When I joined Adyen, I start going over all the configuration, all of these things. And I kind of ask myself, is this why we are doing this? Maybe there is a different way to do this. Is this really necessary? It's why we are doing all of these custom vacuums we have around. So I went to talk with Milan, that's a brilliant engineer in my team. And I was asking why all the time. And I swear he looked at me with his face. I will never forget. And yes, the truth is, why is this so difficult? At the end of the day, it's all about wall generation. So write-ahead logs. Whenever you do a change in the database, this change gets written into a log. And if you have replicas, this log needs to go to the replicas. And it's all about how can you manage this wall generation and keep it under control somehow. Because again, if you have replicas, you need to ship these things to multiple places. And is vacuum that bad? I can promise you it is. Try to vacuum I don't know, 20 terabyte table with a couple of indexes, and then we can talk. It takes days. It's not doable. By the way, don't have 20 terabyte tables. Just another no.
Let's push it. I think the upper limit is 32, right?
Yeah, for 8 kilobyte, yes.
Yeah.
Page, yes, yeah.
So we're getting sneaky.
Yeah, but don't
8 kilobytes.
Don't put like 16 kilobytes and then I can go to 65. No, that's not the way to go. No, definitely not. But yeah, after all of these whys and existential questions, let's go to the hows. So vacuum, we have this amazing process that's called auto vacuum that basically aims to take care of vacuum for you. Aims. The most important things I would look at around auto vacuum is these parameters. Check your thresholds, check your scale factor, check the analyze. That's very important to keep your statistics up to date. Log what you need to log, because if you don't log how long it takes your vacuum takes to run, and then one day it's taking too long, how can you compare? So you need to log this information to be able to go back and analyze if needed. So this is like a 101, very simple. Everyone should tune these parameters. The defaults are terrible, sorry. But now we do some more things to be able to manage these databases. And there are two parameters, two vacuum parameters, so to say, that one is related with the cost and the other is related with the delay. What does this mean? So imagine this is like a very simple representation on wall generation. When the vacuum cycles are running. So you have the cost is the units of cost that vacuum is allowed to consume during one cycle before it needs to sleep. And the sleep is the delay, so it's the horizontal one. And this is a very tricky balance to get, because let's just increase the cost a lot, so vacuum can do lots of work before it needs to sleep. But then what happens? Or if you increase the delays a lot, so vacuum can sleep a long time and doesn't consume any of your resources, but then what happens? And I will try to show you. So the wall generation is essentially like the area. This is a math place, so you probably know all of this. This is a very simple representation. It's more kind of a triangle shape than a rectangle, but it's just for illustration purposes. So like I was mentioning, what if we just increase the cost? Imagine this is your vacuum cycles, and you have this wall generation. So far, so good. Let's increase the cost and allow vacuum to do more work before it needs to sleep. Focus on a certain time window, increasing the cost. What you see is now we can do way more work for the same time window. But this also means you will have spikes of wall generation. And if you have very high spikes, we call them bursts of wall generation. Things start to get a bit complicated, because these walls need to be shipped to the replica, they need to be applied on the replica, and then your replica is getting delayed comparing to your primary, because it needs to go over all of these changes. By the way, vacuum also produces walls, so just for you to know, it's not just when you are inserting stuff. What if we make vacuum sleep a bit more between cycles? Could it help to avoid these bursts of wall? Focusing on the same picture we had before, same time window, and now we increase the delays, which means we still have some spikes of wall generation, but we have them a bit more far apart, which allow us to have a bit more time to cope with this. Again, this is a very difficult balance to strike, and we have very different configurations in different systems depending on the usage. But we don't stop here. We still do a bit of more with vacuum. I call it ruthless. And what do I mean by this? So we have a series of custom scripts that get triggered or trigger vacuum depending on certain conditions. I will just highlight some of them. So for instance, we check our top bloated tables and we actually pick the order in which they should be vacuumed in that specific trigger, because we know the table's utilization and we know which ones are more important to vacuum first or not. It's all about knowing your databases and how your data is accessed. We also freeze things a lot. I will not go into much details, but we also have vacuums being triggered to avoid wraparound. Anyone knows what is wraparound?
Unfortunately.
Unfortunately, okay, yes, that's a good one. We also have some scripts checking for top big tables that are not changed for a long time. So then we just freeze them, vacuum them, and it is and I want to highlight the last one. Anyone here knows this parameter? The lads, good, stay like this. So we use this a lot, unfortunately. And why do we use it? Well, let's see what someone said, this brilliant sentence that I think I will not say it better, so I'll just read it. So unless you are sure you know what you are doing, that is, you are in a wraparound point emergency, please pretend this option does not exist. Really. Christoph has this written in the internet, so it was, I didn't make it up. This exists. And this is absolutely right. Because what this option does is it vacuums your table, but ignores your indexes. Because, well, indexes can take time and so on. And then vacuum is running for 3 days, and then you start getting alerts because wraparound and so on and so forth. Before I go here, I want to ask you something. Imagine you have this option enabled. You spend months using this option. It means that for months you don't vacuum your indexes. Would you trust your indexes after months of not being vacuumed? Yes, so the planner might stop trusting them as well, which is not ideal. So don't forget, if you ever have to use this, don't forget to re-index, rebuild your indexes, take care of that. There were great improvements done in Postgres 17 around vacuum, so if you are not on Postgres 17, upgrade. It's the best advice I can give you around vacuum today. Another final note about running manual vacuums is don't forget the analyze, because auto vacuum takes care of this for you. But when you run manual vacuums, yeah, well, you just run the vacuum, you don't run the analyze. So you should take that into account if you rely on manual auto vacuums. Oh, my favorite topic, backups. Any ideas how we back up our databases? Suggestions? Or a solution, because I'm open to that as well.
Replication.
We rely on replication a lot for disaster recovery purposes, but will that would that help you if you have a logical corruption or something? Yeah. So I can tell you that we do not use PG-based backup, even though it's an amazing tool. Well, I'll be fair. We do use it for smaller environments, but not for like the big databases. And I think I have a slide forward after about the improvements on vacuum. Sorry, not vacuum, backups. But before, I want to go to some very scientific math. And my apologies, because I didn't realize this was a math place. I'm an engineer, I promise. I studied math, but this is very, very simple math. So for me, a backup is as good as a backup and a restore. So if you don't test your restores, for me, it's the same. You don't have a backup. Sorry. You can claim, oh, I have backups in 3 places. Yes. Do you know how long it takes to restore them? No. Okay. You don't have backups. That's it. Because if you don't restore your backups, you might have to end up reading this book, which might exist or not. Backups. And then you ask how you do it, because PG-based backup is not really a way to go in most of our databases. It's very simple, very, very simple. We use storage snapshots, and we back up the walls for point-in-time recovery. So everyone asks lots of things about these storage snapshots, and I will tell you right away. We use very fancy storage devices that are able to do these things. That's essentially the question and the extent I can talk about it. Much more about it. But I was just kind of lecturing you about backups, restores, and now you can ask, how do you restore these things or how you test these things? And I will tell you, we have clones, lots of clones. So what we do is we provision daily clones of our biggest systems for the developers test. They are used for testing the release scripts, to test new features, to even run some reporting. So it's not just about testing the restore procedure, it's actually testing if the restored data is there and it's as it should be and working. So that's the way we do it. Oh, I was pretty sure I had another slide here. But anyways, PG-based backup, I want to say something about it. In Postgres 17, Robert has implemented the incremental backups, if I'm not mistaken, which it's an amazing implementation. You also have Barman or PG backrest. But the problem is, even if you can take incremental backups, you always have to take a full backup first. And then you take the incremental backups and you also backup your walls. And you want to take a full backup now and then, because what happens if one of your incrementals go away? So, and these full backups, they are simply impossible for us to take in the first place. So now I want to talk about some of the things we do around the data and how we store the data to help us with this, to help us to manage these databases. Any idea where this picture is?
Rijksmuseum, yeah.
It's in a, yes, exactly, Rijksmuseum. Have you been there? I hope so. It's really nice. You might ask, do you really need to keep all of this data? Like, why don't you just delete it? Yes. So we actually need to keep all of it, but we also need to be honest. Do we need to read it all at the same time, all the time? Maybe not. I will get back to that later, but before I want to talk to you about the first optimization that we do, and I call it get your columns in order. I've heard it all. It's over-engineering. This is nonsense. It's 5% of less storage. Why you do it? But we do it. That's bottom line. And I will show you what I mean by get your columns in order. So imagine you have this very simple table, 4 columns, just a Boolean, integer, small int, big int. And I have this, again, simple record. Just one table, one record. I will use the page inspect extension to show you how these values are being stored at the page level in Postgres. And if you use the extension, you will get something like this. This was run for a 64-bit system. So in a 32, it might differ some bits. So first one is the Boolean, next the int, the small int, and then the big int, if you remember from the previous slide. And the empty part, like this empty part here, is what we call padding. I think we can do better than this because it seems a bit of a wasted space, right? And what can we do to make it better?
Figure first.
Figure first, yes, that's a good way to put it. Yeah, so here I reordered the columns and I will show you how I did reorder the columns. This is the same record, I just swapped the columns around. So first, big int is the first to go. The int, the small int, and then the Boolean. And now, do you see the difference? I know, maybe this is too much for a small gain, but is that gain that small? It might not be. Some more super scientific math. It's 10% of 100 terabytes is, well, 10 terabytes. If your databases are, if you have hundreds of clusters like we do, we have several clusters that are way bigger than 100 terabytes. Then we have replicas, at least 3 of them for each cluster. You are doing the math, right? And then we have backups as well, because again, you should have backups. These things really compound. These savings really compound if you take into account all the places where you have your data. There are lots of more details into this, to be fair. This was a very simple, again, example. If you want to learn more about this, there are some gotchas around it. Go and listen to the column Tetris on the Post FM podcast by Nikolai and Michael. And Charlie Batista gave this brilliant talk 1 year, almost 2 years ago, oh God, at FOSDEM. It's recorded, so go and see it because he has way more complex examples. Really good one. Before we go to partition, another side note is when you are thinking about doing these optimizations is because you probably are at a very bad situation already. You already have very big tables. You don't start thinking about these things if your databases are 100 gigabytes. And the problem with having big tables is how do you manage to change your column orders without any downtime? Yes, that's another requirement that we always have, no downtime, ever. So you might not be even able to do it. But if you partition your tables, which I hope you do, you can actually, since Postgres 13 onwards, you can, for new partitions, you can define a new column order as long as you keep the same column names and types. You can like for the new partitions, you can reorder the columns. And from those new partitions onwards, the data will be more occupying less space, so to say. And well, of course, the older partitions will stay as they were. But well, if you are doing some data retention kind of strategy, you will eventually get rid of the older partitions, and then the new partitions are all nicely shrinked. So that's a good one to consider as well. And now we go to the partitioning, because again, there is this limit of 32 terabytes per table. And I would say, if you have anything that's bigger than 100 gigabytes, and it's not configuration or static data, just start partitioning. Save yourself, your future self, the trouble, because you will get into troubles. And I like to think about partitioning like this. We have a big problem, so let's just break it into smaller problems. Because having a big table, it means vacuum will take a long time. Your index creations will take a long time. And then if you have lots of big tables, your backups will also be a problem. So just break your problem into smaller ones. One table, this works perfectly fine. But I'm pretty sure you don't have one table in your databases. And then you might end up in this situation. What is this?
Joins.
Sorry?
Joins.
No, this is just partitions that are misaligned. So you have different tables, table A, B, and C. So table A, we started partitioning it at some point in time. Table B already existed, and we just decided, well, let's just partition from now onwards. And then for table C, we kind of learned our lessons, and we decide to partition it in a proper range and so on. But the problem is when you need to join all of these tables, because I'm pretty sure you have queries that join lots of tables. If you need to query something that is between 1,000 and 2,000 with something that's on table B and then on table C, you might have to end up scanning a bunch of partitions just to get your results. And this has a very bad side effect. That is, anyone ever had in their monitoring systems these lightweight lock manager events? Okay, so you are very lucky. So Postgres has this amazing implementation that is called fast path locks. So you have the lock manager that manages all the locks. If you are reading or writing wherever, there are different types of locks in Postgres, and lock manager manages them. But then you have these fast path locks that if the lock you are trying to acquire respects certain conditions, it can go through this fast path. It can go over the normal lock manager. And it's faster, like the name says. But there is a catch. There is a limit to the amount of fast path locks that you can have. And the problem is if you have lots of partitions, and if they are misaligned, especially, you have to go through several partitions for several tables, probably several indexes, because I hope you use indexes as well. These fast path locks limits are very easily to be hit. And then you start seeing all of these lightweight lock manager events in your monitoring, which whenever this amount of fast path locks is exhausted, you then have to go to the normal locking mechanism, and that just takes more time. What's wrong with this picture?
Plenty of tables, plenty of indexes.
Sorry?
Plenty of tables, plenty of indexes.
Yeah, probably, yes, but yeah, most likely.
Planning time dominates.
Sorry?
Planning time dominates instead of the execution.
Yeah, how the hell does the database spend like 120 times more planning my query than executing it? It's like, what the hell is doing?
It's a very good plan. Execution is
Yeah, that's the thing, because the database always wants the best plan. And to get the best plan, it needs to calculate them. And it doesn't calculate just one. It calculates multiple plans, and then it picks the less costly one. And again, when you have lots of partitions, lots of different combinations need to be evaluated. So again, your planning time can just go crazy. Whenever you are tracking execution times, don't forget about tracking planning times as well, especially if you are relying on partitioning a lot. We do lots of partitioning at Adyen, lots of them. We even developed our own framework for partitioning. There are other extensions like PGDay, I think. I hope I'm not saying it wrongly. But yes, we developed our internal one. You can check it. It's publicly available on GitHub. And because we love partitioning so much, we write about it a lot. And so all of these articles are in our Adyen blog. You can easily find them with your amazing Google skills, I'm pretty sure. Now I want to talk to you about data temperature. Remember when I said that you might need to keep all of the data, but I'm pretty sure you are not reading it all the time? That's what I want to tell you. So you have this hot data. Imagine we process payments. So you make a payment. This piece of information is really important for today, maybe for a week, because you might need to get a refund or something. So we call it hot data. It needs to be easily accessible, very, very fast. But then this data kind of loses a bit of importance in the sense that you might not change it, but you still need to have it accessible somehow because you want to run reporting on it. So we call it like warm data. But after 1 year, are you actually returning wherever you bought 1 year ago, or expecting to get a refund? But you might be able to, but it's not a very common case. So we just offload this data to, we call it cold data, and we just take it out into a secondary storage because it doesn't make sense to have all of these huge amount of data all together in the same place. So that's what I wanted to say about data temperature. Now I think this is one of the last topics, query performance, and it will also go back a bit to planning time and partitions. One of the ways of getting away with high planning times is use prepared statements. Because if you use prepared statements, the plan is calculated once. Well, it's calculated a bit more, but let's say the plan is calculated once and then it's just reused. That's it. You skip all the planning phase, you don't do it anymore. You just use your prepared statement. This works for similar queries, of course. You can have different parameters like ID equals 1, 2, 3 or ID equals to 3, 4, 5. Doesn't matter, but as long as the query is the same, the plan can be reused. But be careful because you need to know your data distribution. Because if you have very skewed data, a plan that is built for a certain parameter where it was trained on, it will not be the best plan for another parameter. A very common case is whenever you have like these flags, like true and false. So you might have like 99% true and 1% false. So the plan you train in either of these options is not the best one for the other one. But for that, you can, there is another trick that we use on top of that. So you can have, you can force generic plans, but then if you know that your data distribution is skewed somehow, for that specific query, you can force a custom plan to be recalculated and executed. And you can define this at session level. So you can have all your database using generic plans, but then for specific queries that you know that need to be recalculated, the plans need to be recalculated, you can use custom plans at session level. Anyone here is from, I've worked with Oracle before? Okay, this was one of the things I missed the most because I came from Oracle databases. So this is just a big shout out to Lawrence Albe that also replies to everyone on Stack Overflow, by the way. If you have Postgres questions, he will always reply to you. And yeah, he introduced this amazing feature that allows you to run explain on top of generic plans. That was something that was not available before. And finally, the wrap up. I did not ask the meetup organizers. I hope it's fine, but we are hiring. I hope it's fine to share. And just to convince you, this is the view from the office. So feel free to check it. You can find, well, you can go to QR code or you can just check our careers page. My team is hiring, so Amsterdam or Madrid, if you prefer. Yeah. Now let's go for the wrap up because everyone wants to go for pizza. So initially we start by seeing that what actually big databases mean. It's not just about the size, it's about the latency requirements, it's about how many TPSs you are expected to have or not, how much data you need to keep around or how much data you can offload to secondary systems. Then we talked about how to bring balance to the database, just have your writes on one place, your reads on another place. Then, of course, vacuum, lots about vacuum. I will not repeat everything. My favorite topic, please have backups, have backups. No one wants to get that call, especially on it's always at Fridays. I'm not sure why. I have this thing that's read only Fridays. I try to implement it, but some people don't really like it. I don't know why. But anyways, having someone calling you on a Friday, oops, I ran an update without a where clause. Yes, you should have backups for those things. And finally, I shared with you some optimizations we use to be able to save some space and have these databases a bit more manageable. There are still lots of headaches there. So anyways, I didn't even cover major upgrades because that would be like a different, a whole talk just about major upgrades. And that's basically it. You can get the slides if you want. And again, we are hiring, so just for you to know. And if you want to ask any questions, I will be glad to answer them. Questions are and only easy questions, by the way.
So if you do use partitioning a lot, you always have the partitioning key in the queries then, otherwise I assume secondary indexes is out of the questions.
Yes, the partitioning key needs to be, has the primary key, yes. Yeah, it's kind of the way it works. At least it works for us.
Yeah, because there's no global indexes.
Yes, that's another thing I miss from Oracle. Don't tell anyone. But yeah. Questions? Yes.
Thanks for the talk. Really interesting. Maybe it's an opinion question, but you can also answer technically. Like, is vacuum like necessary complexity or like accidental complexity?
Oh.
Like, it seems like MySQL doesn't have vacuum, and they seem to be doing fine. Like, is it really?
It's really bad. Yes.
No, but like, you know, why? Like,
Why vacuum is needed?
no, like, is you know, does it really provide? I don't know. Like, maybe it's better performance because you don't, I don't know, spend time cleaning up your disk. Like, Is
If you
there,
don't connect up, you can run out of transaction IDs, and then what?
no, I mean like what, let's say, why is vacuum, let's say, a better solution, like, to delay, let's say, the actual, clean up of the disk instead of like cleaning up the disk when you delete the rows?
Oh, that's the way Postgres works, by the way.
But is it, is there a good reason for that, or just, well, it was easier?
It was the implementation that was done. I'm not sure. Maybe behind you, they know a bit more about these implementation details.
It depends in the end how you implement your version control. So most of Oracle mostly has a undo log, I believe. So changes are made in place. And if you read an old snapshot, you look at the undo log. Postgres implements a redo log. So, and that requires that you have your old tuples marked as deleted at a certain version. And that is what vacuum solves, because if you don't remove those rows at some point, you will run out of the transaction IDs. And that's the wraparound problem that was talked about.
And your database becomes read-only, which is not ideal, because if you want to kind of process payments, it's a bit annoying if you cannot write to the database.
I think it simplifies the MVCC implementation within the database. Having the ability to keep the old tuples, right?
Yes.
Essentially what
Well, it's a decision. So it's simple in its implementation. It's complex in its operation.
Okay.
Trade-offs, you remember? It's not just about replication, it's about everything else. More questions? Yes, here in the front.
Yeah, so regarding backups, so you mentioned that you're using the storage system snapshots for that.
Yeah.
I also work on this similar project for MySQL as well. So I do snapshots from the storage systems and then plus carrying the binary logs, which is the write-ahead log for Postgres. One problem I faced is that when we do, after making a couple of snapshots, I think that the disk performance kind of degrades, probably due to the fragmentation in the storage layer. So what I have to do is like to manually vacuum those things. So I just throw all the snapshots away and I spin up a new disks and copy everything from that one. So this is something I have to do to ensure the disk performance is good, okay-ish.
Yeah.
So I wonder, do you face some problems similar to this as well? And if not, could you tell me the storage provider you're using?
We'll start by the end. I cannot disclose what storage providers we use. But this snapshotting is a feature from those storage devices. And they have a separated, dedicated space to store these snapshots. So this disk fragmentation, I don't believe it's something that we face. But next time I'll bring someone from storage team and maybe they'll.
So then just a top question on that. So just keep snapshot on snapshot on snapshot on snapshot forever, basically, and that works.
Well, we cannot keep all of them all the time.
No, but you delete some older snapshots, but the reference is the storage system handles the referencing.
Yes, yes. We take it's volume consistent snapshots that we are able to accomplish with these fancy storage devices, like I call them. I had a question over there.
Yeah, it's more of watching your talk. Very, very good, very interesting. If you could start over again, would you use Postgres?
I don't want to hurt anyone's feelings. I've worked extensively with Oracle before, and Oracle is kind of the best you can get in terms of databases. Like if you have a rack and if you can use, if you use ASM and if you can put your hands on an Exadata. But honestly, I would not go back. I would still use Postgres, but I would definitely make some different decisions in terms of the architecture that we currently have in some of the systems that we have in the company. Yeah, but no, I would not go back.
In Vitesse?
It's working in Postgres. We can.
Yeah, so we have had a few recent examples of people moving from Postgres to Vitesse. I think it will change in the future. I think sharded Postgres will come. Postgres is improving leaps and bounds. But right now, I think still for a lot of large solutions, MySQL is still better, maybe Oracle are not used, but better for like huge systems. It's changing. I think in 2-3 years, Postgres landscape will look very different.
It's changing, definitely. Yeah.
Thank you.
To follow up on that, then have you ever tried like Yogabyte or Cockroach or any distributed SQL database that Postgres compatible?
Okay, so Cockroach recently closed source. That's
No go?
a problem. It's not a no-go. We actually have some Cockroach internally, but the philosophy. Oh my God, the word I cannot say. Yes, of the company is to use open source as much as possible. So that's the primary decision factor is open source or not. So that's one of them. Yugabytes. There have been some internal talks, but we feel we need to wait a bit more. And it's also a commercial product, if I'm not mistaken. Yeah, it's well, maybe I'm saying some nonsense. It's a licensed or it's a fully open source.
I think it's open source.
It should be open source and they should have some support as well. I'm not sure if
Yeah, that's the support is another question because then you use this specific system who supports you if you need.
Yeah.
That's another question. And also having an exit strategy or a compatibility, it's also some other aspect that it's considered whenever we are picking a new software.
Yeah.
Not saying that they are not good,
No,
but it's things that we need to consider. It's financial data, right? You really don't like to wake up in the morning and not being able to log in or your balance is at 0 or something like that. So we really take care of it.